In this video, we're going to look at two questions on the topic of Doppler effect. So for the first question, it says a man blowing a whistle of frequency f moves away from the observer at speed u, and then derive the formula of the frequency f1 heard by the observer. And then it gave us the velocity of sound is c. If a man blowing a whistle of frequency 500 Hz moves away from a stationary observer towards a fixed wall in the direction perpendicular to the wall at 2 meters per second, determine the beat frequency heard by the observer if c, the speed of sound, is equal to 330 meters per second. So in this case, there's two questions, so let's look at the first questions. It says, what the question wants us to do is basically derive the formula for the observed frequency due to a moving wave source. Okay, so first of all, what I know is that let's set the observed wavelength as lambda dash, and then it is basically equal to the initial lambda plus, because the wave source moving away, this basically means that the wavelength observed should be increasing, so therefore it's plus a difference in lambda. Now we have to express this, so we can express wavelength as the speed divided by frequency. So therefore, in this case, for lambda dash, it is basically equal to the speed does not change because it's still sound. However, the frequency changes. So therefore, it is equal to c over the frequency 1, I suppose. Yeah. And then this is equal to this is initial one, so initial frequency plus now the difference I would say it is equal to the speed of the wave source over the initial frequency. Speed over frequency. Okay, so then what we have to do is simply solve for f1. So we can multiply both sides by f and f1, which gives us cf is equal to f1 c plus u. And then, so f1 is simply equal to f c over c plus u. And this is simply the equation for f1, the observed frequency. Now let's look at the second question. It says it gave us the frequency, initial frequency, and then it gave us the speed of the wave source. Determine the beat frequency heard by the observer. Okay. So essentially, what the question is getting at is that a person, which is essentially a wave source, is moving towards a fixed wall, and then the idea is that the sound will bounce off the fixed wall and then to the stationary observer. So therefore, in this case, the stationary observer is basically observing two waves. One that is directly transferred to him, which is the effect of the wave source moving away, and then another one is the effect of wave source moving towards him, which is essentially the wave that the stationary observer observes for the one that is bouncing off the wall. So in this case, the beat frequency. So what I know is that the beat frequency is equal to the difference in frequency observed. So therefore, what we have to do is simply to calculate the difference in frequency. So first of all, what we know is that, let's say f max for the moving away, so that will be equal to 500, and that's 330 because it is moving away, so therefore it's plus 2, and then And then let's calculate this. So this is 500 times 330 over 332. So that is 496 points. Let's go to 3 decimal places. So that is 988 hertz. And then let's see. So F min. Oh, I think it's the other way around. Yeah, no, wait. So that's 500, and then it's 330 over 330 minus 2, which is 328. And then that is yeah. So that's 503.049 hertz. I'm not going to change the signs because okay, so therefore we will be able to calculate the beat frequency, which is equal to minus 496.988, and that is, let's say, 6.6 hertz, and that will be the answer to the question. Now let's see question 2. So it says, a car traveling at 90 kilometers per hour in a straight line sounds its horns continuously. Frequency 400 hertz. As it passes a stationary observer at the closest point A to the observer, the car is at a distance d to 100 meters from the observer. Determine the frequency heard by the observer when the car is at A and at a distance x from A after passing A. Okay, so it gave us the speed of the wave source, right? And then also the frequency and the distance to the wave source. Okay, so let's first look at question 1. It says at A. So essentially in this case, A is the closest point, which should be perpendicular to the motion of the car. So therefore the frequency observed should be the initial frequency. This is because there's no movement towards the stationary observer, so therefore the frequency must be conserved. Now let's see the second part. It says at a distance x, so therefore in this case the question would like us to derive a formula. And then okay, so let's draw a simple diagram. Let's say the car is over here, right? It's moving at a certain speed that is 90 kilometers per hour. I think I'm going to convert first. Okay, so 19 kilometers per hour, so that is 90 times 1,000 over this, and that is equal to 25. Okay, a rather nice number. 25, that is the car, and then the idea is that this is distance x, and then this is the observer. The observer is over here. Say it's a square shaped, okay. To differentiate it, and then the d is 100 meters. So let's see. My idea is that we can calculate the angle, derive the angle from x, and then we can link it to the velocity of the car directly away from the observer, and then from that we can derive an equation for the frequency heard by the observer at a distance x from A. Okay, so let's see. What exactly is the angle? in this case, let's say this angle. This angle is theta, and then so therefore tan of theta will be equal to x over 100. Okay. And then what we have to do is to calculate. Okay, so over here, this should be 90 minus theta, because this is theta. So therefore, in order to calculate that, it should be equal to 25 sine of theta. And then so essentially what we have to do is calculate the sine of theta. In this case, we only have the tan of theta. And so maybe we have to utilize Pythagoras. In this case, the hypotenuse is equal to that's 10,000 plus x squared. Not sure whether this will actually work out. Okay, so therefore what we know is that sine of theta will be equal to x over this. Okay, we got the sine of theta. So therefore the speed will be equal to 25x over this. This is simply equal to the speed. And then what we can do is plug this into the equation. So therefore F observed will be equal to the frequency, which is 400, C, which is 343, I think it's given in the question. Yes, 343, and then over 343, because moving away, so therefore it's plus 25 x over and then I don't think I actually need to simplify this. Yeah, and then this will be the answer to the question.